A very good morning to all of you. Once again, we are back and we will continue from where we left yesterday. Okay. So, good morning once again. Good morning, those who are joining now. So, in the last class, we were discussing about straight line. We saw the slope of a straight line. We saw the coordinates of a straight line. If you have 2 points given, then how to find the slope, how to write the coordinates, distance formula, all this thing, right? So today we will be seeing about the terms like rest, motion and all. But before that, we will quickly go through what we call as, yesterday I told that we have to study also about the equation of a straight line. So yeah, fine. Slope and coordinates we had discussed. I had told you the quick method of finding. Now, we will now come to the equation of a straight line. Now, when we write the equation of a straight line, so basically you will remember whenever we take two variables y and x, if I take two variables y and x which are representing any two physical quantities, then if we have a linear equation between y and x, where y and x are two physical quantities being related with each other. So if we relate two physical quantities with each other, and if there is a linear relation or linear equation, you will say that it represents a straight line. So how we find the equation of a straight line, or what equation basically we have to use? So we can say the general equation is of the form ax plus by plus c is equals to 0. So if you have a linear equation ax plus by plus c is equals to 0, where a, b and c are constants, a, b and c are constants, then this equation will represent a straight line. Now, how do you trace the straight line? What is the method of tracing the straight line? So what you will do here, see, we know that when we take y-axis, on y-axis the value of x is 0. When you take x-axis, on this line we know that y is 0. So if you have to find or draw the line, what you simply need to do is first put x is equals to 0. If you put x is equals to 0, we get the point on y-axis, because when you will put x is equals to 0, the point will lie on y-axis. Similarly, if you put y is equals to 0, we get a point on x-axis. So the strategy is you have to find points on x-axis and y-axis, and once you get these 2 points, final what you have to do, join the 2 points to get the straight line. So whatever, it is not hit and trial method, beta. Hit and trial is something else. Hit and trial is when you assume something. Here it is not hit and trial. You are actually getting the point we are getting on x-axis by putting y is equals to 0. Point y is equals to 0 you are getting point on the x-axis. So it is not hit and trial. So it is good that sometimes we should be using some good English words or phrases, okay, but this is not trial error or hit and trial. So it is actual thing which is being done, right? So focus over here. So this is not a hit and trial method. So whenever we have to draw any graph, keep it in your mind that we have to put once x is equals to 0, once put y is equals to 0, you will get the points. So now let's try doing this and getting the equation transformed into a graph. So when the equation is given, any linear equation, ax plus by plus c is equals to 0, just you have to do what? Just what you have to do is someone teach somewhat advanced. Now you will see example. Who is this? Sandeep. Beta, for advanced, first at least learn something for beginner. Okay. So one should always leap for heights only when you are aware of safely landing on the ground. If you are not aware or not sure that I can land on the ground safely, we should not fly high. Everything comes at a level. And most welcome when you all will be here. So whatever you want to know in advance, you will be learning that time. Right now, learn the basics at least. If the foundation is not good, then you cannot build big buildings over that. It will guaranteedly fall down. So here, let's see equation. Now, example, suppose I have to draw a line. They have given the equation 2x minus 3y is equals to say 12. Now you can see now if we see this 2x minus 3y is equals to 12, it is a straight line equation. Okay, so 2x minus 3y is equals to 12 is a straight line equation. Why it is a straight line equation? Because you can see that the equation has a linear form for x and y. So what I do, just see, as I told, just put y equals to 0. If you put y is equals to 0, you get 2x is equals to 12. That means x will become directly 6. If you put x is equals to 0, you will get minus 3y equals to 12. So from here you will get y is equals to minus 4. I hope it is clear. Now the last step, what I said, just draw the two axes x and y, this being minus y and this being minus x, and now just mark the 2 points. What are the 2 points? You can see x is equals to 6. On x axis it is 6 here somewhere, and y is equals to minus 4. Y is equals to minus 4 is here somewhere. So now what I have to do, I have to just join these two, as I said, by a straight line. So if I join these two by a straight line, that's it, you got. So this point coordinate, it is on y axis 0 comma minus 4. This point is on x axis 6 comma 0. So this is our required straight line. So y is equals to minus 4. I hope I have written that only. Minus 3y is 12. So y is equals to minus 4. Is it clear? Okay. I hope it is clear. Now, if 2 points or any 2 points on a straight line are known. Suppose sometimes what will happen, you will see that any 2 points on a straight line are known. Say x1 y1 and x2 y2. If we know these 2 points, then what happens? By putting x1 y1 in the equation of straight line, general straight line ax plus by plus c is equals to 0. So we can find the equation of the straight line. How we find that? See, if 2 points on a straight line are x1 y1 and x2 y2, so what we just do, if we take the line equation as ax plus by plus c is equals to 0, so first you will put for first point, you can write, put x as x1, y as y1. Then put x as x2 and y as y2. So when you solve these 2 equations, we directly get the equation transforms into some form which you can easily remember, transforms into y minus y1 is m into x minus x1, where m is nothing but what we saw yesterday, which is slope of the line. So if sometimes you see that a graph is given and you are not able to figure out, or you are not able to, because those who are thinking advance, wait for kinematics to come in graphs, these are the students who first say that, sir, we are not able to understand anything, it became very difficult, right? So at least learn the coordinate geometry concepts first, then you will see when graph based problems will come, how effectively we can use them. So this can be used as a formula, very powerful tool, slope of line if it is known, and if you know any 2 points, by putting them in a general equation, we get the final form reduced like this. So slope of line, so slope of line, if it is m, and if I take 2 points x1 y1 and x2 y2, then you can use, if I am using y minus y1, then I will take slope into x minus x1. And yesterday I told what is slope. Slope is nothing but change in y coordinate, y2 minus y1 by change in x coordinate. So one more form of equation of a straight line which you should remember. I will tell everything with examples. Don't unnecessarily type and waste your time as well as the time of other students. So here we will see this by also equation. Okay, and one more thing, I will justify this question which I said, here we had the equation and I got this line, I will justify this equation by that also. So you will see that, so y minus y1 is m into x minus x1. So if I know the slope as y2 minus y1 by x2 minus x1, which I discussed yesterday, then I can write the equation like this. Is it clear to all of you? So this is an important equation. So please, I have told it repeated times, beta. I think if you have not joined today, if you have come earlier, then you would have heard me saying a lot of times. You are studying right now on YouTube, which is live, and you always have the option that after the classes are over, all these things are fed and they are uploaded. All these are fed and uploaded. So you will, whenever you are studying again, you can easily read them and write them also. Don't worry about that if you are not able to write right now. Someone is saying, sir, should x be x2 and y should be y2? Beta, x2, y2 is upon us. Suppose there are 2 people, one is A, one is B. Now it is up to me. If I take one as A, other one is B. If I say first one is B, other one is A. What is the problem in that? So if I take any point, I can take as y2. Then if you have written y2 in the numerator, x2 you have to write in the denominator. If you have written y1 minus y2, here I have to write x1 minus x2. Yesterday I told this thing. So anyone can be taken, and similarly here, if you are writing y minus y1, you are bound to take x minus x1. But if you are taking y minus y2, then here you will take x minus x2. Understood? Listen again. If you are taking y1 here, you will write x1 here. If you are taking y2 here, you can write x2 here. No beta, these all things will not be taught in college again. Directly after today, you will be writing the NEET exam directly. Means after hearing the class today, directly in 2027, I think, 2027 or 28 you will be writing NEET exam directly. What you studied in zoology today, what you will study in botany today, after that classes are over. Now you can peacefully enjoy at your homes. Nothing more to study, nothing will be taught to you again. Directly they will say write the exam. Okay, so if you are now happy that yes, now we can enjoy, then we shall proceed with the other students who are more interested in what is going right now instead of cribbing about the future. So here, this straight line, let us cross check by this. I said the equation of straight line was given here. See, I am cross checking by what I taught. 2x minus 3y is equals to 12. See here. If I want to see this one, I said y minus y1 is mx minus x1, right? Let's try to cross check that this equation will give me this or not. If I said, suppose I take this one as x1 and this one as y1 and this one as x2 and this one as y2. Let's try to write with what form I said here. Clear? So y minus, suppose I take this as y1, y minus minus 4 is equals to, let's calculate the slope here first. Slope is y2 minus y1 by x2 minus x1. What is y2? y2 is 0. What is y1? Minus 4. What is x2? x2 I have taken 6, x1 0. So we are getting plus 4 by 6, which can also be written as 2 by 3. Now here I am putting slope as 2 by 3. When I have put y as minus 4, I have to take x as x1, that is 0. So I will write x minus 0. Let's see. 3 multiplied this side, y plus 4, 2x. This means 3y plus 12 is equals to 2x. This means 2x minus 3y is equals to 12. Now kindly check the equation that I have written here and the equation that I gave here. Are they same or not? Are they same or not? Understood? Same. Okay. Now, beta, I said now whatever you do, you can take x1, y1 opposite also. Now see, I will again change and I will show you, since there should be no stone unturned for understanding whatever is being taught here. If you are having any confusion, let's change it. I am taking, suppose I reverse. If I use the equation, will it be of any harm if I write y minus y2 is m into x minus x2? Let's try now this. Let's try this. So this y minus y2. Now if I take y2 is 0. Slope for a straight line, slope is same only. Okay, slope is same only. So slope is 2 by 3. Now if I have selected y2 as 0, then I have to take x2. What is x2 here? x2 is 6. So I will write x minus 6. Let's cross check now again. Multiply 3 into y comes this side. 0 is gone. This side 2x minus 12. again take 12 this side, 3y that side, and you will be not at all surprised to see that same form comes. Check. Okay. Football, anime. Sir, you are teaching day by day is, you are showing a graph. Beta, see, whenever a teacher or a student, that's what I was explaining, the importance of basics. When we start going basic to basic and then we keep on going up, then you will see that the improvement will also gradually be observed. There will be less decline, more improvement. है ना? If you are cooking biryani, you want to have the most delicious biryani, then what you should do? You should first soak the rice for some amount of time. You should have all the masalas and ingredients ready. Everything should be done in a strategic way. Then finally what is served on your plate, it will taste so delicious, then you will be able to enjoy it. Not like that, sir, what if I do advanced first and basic later? Then what will happen? Just opposite. There will be continuous decline. You will neither be able to understand advanced nor the basics, and one day you will say, sir, I am thinking my preparation for NEET is done. I am not no more confident that I will be able to write the exam because I don't know anything. So it's better. Okay, yes, definitely you can buy in a shop, and when you buy in a shop, that will also, it is not that a god is sitting over there and he is just giving his hand like this and biryani got cooked. There also labor is involved. They are also from the morning, since morning they are preparing, then you are able to enjoy it. Okay, I have answer for every question of yours like this. So wherever you eat from, it will not come naturally. It will not be hanging from a plant so that you can just go and pluck it and eat it. So kindly focus on the class. So if anyone else is willing to continue with fun elements or being roasted, we will keep a separate session for that where we can do all such stuff. Presently we are into teaching, so kindly focus on studying and let me teach, right? So that will be beneficial for you. So 2x minus 3y equals to 12, one equation I showed. Either by the equation given you can draw the graph, or from the graph if 2 points are known you can write the equation. Is it clear to all of you? Now let's move on and yesterday we have seen slope positive or negative, everything has been taught. You can go through and check yesterday's lecture. Everything was done in detail with shortcut methods of finding slope. So now we move to basics of the next content or chapter, which is rest and motion. But I am not minding anyone. I equally enjoy when I get such comments. The only thing which makes me worry is that those students or those who are doing such activities, they are not present before me. Otherwise the class would be more funny and they would have got the taste of their own medicine. Okay, So I am not at all minding anyone. I'm just feeling sad that these guys are not directly in front of me. They could have enjoyed the class more. Anyways, motion and kinematics, motion and rest. So now let's start with these two terms. Beta, can any one of you tell what you have the basic understanding of rest and motion? What is the basic understanding of rest and motion for you guys? What do you think? What we define as rest? What do we mean by rest? And what do we mean by motion? Everything we are coming. Everything will be connected to each other. Motion means movement. Okay, beta, here first of all we should know that whenever we are telling about a rest or motion, we should know something about position. So I told about coordinates. Coordinates give you the position of any particle at any instant where a particle is. Now, when we say that a particle is in rest, means its position is not changing. Is it a completely correct statement or not? Please tell me fast. If I am saying a particle is at rest, means its position is not changing. So this statement is not completely correct. Yes, I got few answers from here. It will depend on the observer who is observing. It will depend on the observer who is observing. Until and unless I mention the observer, I cannot say whether a particle is at rest or motion. So first of all, let me make this thing clear before you. There is nothing called state of absolute rest or absolute motion. That doesn't exist. So we can say rest is no change in position of an object with respect to, WRT is short for with respect to an observer. As time passes. So as time passes, if there is no change in position of an object with respect to an observer, we say that it is in rest. But if I say that position is continuously changing with time, again with respect to means as seen with respect to an observer, then we say that it is called as the state of motion. So when we have motion or rest, that means the position is either changing or not changing, and that depends on what important term we have used over here, which is called as an observer. In the language of physics, this observer, yes, very correctly written by one or two students. It is in the language of physics, it is called as a reference frame. Whenever an observer is looking at any object, then that observer is called as reference frame. For example, if I am standing on ground and I am looking at any object, so I will say that the object is viewed with respect to ground, and that ground here is the reference frame. If an object is anywhere and I am inside a lift or I am inside a car and then I am watching the object can be anywhere. Where I am, the observer, where I am, that will be called as reference frame. So if I am inside the car, so the object is being viewed from the frame of car. If I am the observer and I am inside a lift, so I will say the object is being viewed from the frame of the lift. So when with respect to a given reference frame, the position of any object does not change with time, the body is said to be at rest. And when, with respect to a reference frame, the position of a body or object is continuously changing with time, it is called, or it is said to be in motion. So it should be continuously changing. Now if I just say position is changing, will I say it is motion? If I remove the word continuously and I said that position is changing, will I say that it is in motion? Please let me know. Will I say if just I write position is changing, but will I say that it is in motion? No, I am saying with reference frame also. I am looking at an object and its position has changed. So will you say it is in motion? Please reply fast. If anyone has any doubt regarding reference frame, I am again repeating. If I am taking any reference frame and suppose that reference frame is looking at an object and the object has changed its position, so will I say it is in motion? No, I cannot guaranteedly say. I am giving an example. You all can see me on the screen right now here at this position. Okay, let me mark here. This position I am standing. Okay, now after some time I came here. What will you say? Am I moving? The correct phrase would be, I have moved from one position to other. But am I moving? Am I in motion? No. I just shifted from one position and came to the other position and I am here. But what is happening? Again, don't confuse yourself and others with observer. I am not talking about observer. Observer live with respect to moving observer. I am saying if I don't use the word continuously, it is to always with respect to observer beta, it is always with respect to some observer. But I am saying that if continuously word is not using, then you cannot say that it is motion. Motion means there should be continuous change in position. The moment the change is not undergoing anymore, you will say the body is at rest. So here, any reference frame, first of all we have to decide who is looking at the object. And then with respect to that frame, if the object appears to change its position continuously, it is in motion. If it is not changing its position, I will say that it is at rest. That's it. No more difficult concept for rest and motion, understanding only this thing. Second important point, from here we can conclude, it always depends on the reference frame. So it is to be remembered that state of rest or motion is always relative to an observer. So they are relative terms. So relative terms, so therefore absolute state of rest or motion does not exist. So we can never have absolute, means you can guaranteedly say that yes, from all frames this object is not moving. You cannot say. So until and unless we are aware of a reference frame, we cannot comment anything about the state of rest or motion. So there is no such term called absolute state of rest or motion. It is always observer dependent. So that's why we say state of rest or motion is relative, not absolute. Okay. Narayana Rao is having doubt. What is your doubt? Please type it, because otherwise how will I know what is going on in your mind? Sir, what is meant by reference frame? Beta, I just told, see what is reference frame? Observer. Whoever is observing any object, suppose you are observing any car, moving car, and you are standing on ground. So you will say that you are observing that car from ground. So the reference frame is ground. Suppose you are moving inside a car and you are looking at a tree. then you are looking the tree from which frame? You are looking from the frame of the car. If you are inside a bus, you are looking all around. So your frame of reference is bus. Understood? Absolute word means which is fixed for all frames. So it is not. Absolute means there is no change. It is constant. So there is nothing called absolute. 100% you cannot say. Okay. So this I hope is clear to all of you. Okay. Now let's see some important terms which we associate while we are studying rest and motion. So when I said that we are talking of change of position, so we use two terms first, which is called distance and displacement. We will be representing distance by the letter D just for our convenience, and we will be taking displacement by the letter S. Now, distance and displacement, how we define distance and displacement in a simple way. For that, first of all, you have to know from where to where you are going. So, if a particle has to move from one point, suppose I am taking A to other point B. Suppose I have this, that a particle has to move from one point A to another point B. So what will be my answer for this? Total number of possible paths from A to B. Take any 2 points. You can take as close as here, like this. I can take this as A and this as B. How many paths are possible? How many paths are possible? Beta, you all are giving bookish answers, some of which are not correct also. Please listen to here first what I am asking, then please try to answer that. I have said that if a particle has to move from one point A to another point B, A and B can be any 2 points in space. How many total number of possible paths are there from A to B? Yes, correct. There can be infinite possibilities. Infinite possibilities. And all the paths will be different from each other. All paths are different from each other. Then whichever path is selected, suppose you select one path out of that, total length of that path will be equal to distance covered by particle. That's it. So whichever path you are following, then the total length of that path will be called as the distance covered by the particle. So what does that mean? Therefore, between two given points, distance d varies from path to path. So distance will keep on varying from path to path, and this distance has no fixed direction. It has got no fixed direction. So this distance, whatever path you have selected, it is meaningful for that path only, and it is a scalar quantity. So this distance is a scalar quantity. It has got no relevance of direction. You can move in any direction. The path length that you are traveling, complete path length, that will be called as the distance between 2 points. Next comes what we call as displacement. Now you all know that displacement is the shortest path. So if I say again now, total number of straight line paths directly joining A to B, where A and B are any 2 points. Now what is your reply for this? What is the reply for this? Total number of straight line paths directly joining any 2 points A and B. How many you will have? Only one, correct? Very good. So you only have one. And this only one which is called the displacement, and this only one path is called as the displacement from A to B. Now what happens when you are going from A to B along a straight line path? Means you have a single direction. So if you have a single direction, that is a fixed direction, and it has got a fixed length also. So that means when you have a fixed direction and fixed magnitude, what do we call such physical quantities as? Please mention. Sir, you should mention shortest. If I don't mention shortest, it is easily understood. Think of, try to tell any other path which will be shorter than a straight line between 2 points. It is self understood that straight line is the shortest path between 2 points. Even if you don't mention these all things, when we are in 8th, 9th class, we are already taught. So simply displacement has a fixed direction, as I said, along the straight line, and the magnitude of straight line is constant. Correct, very good, very good. So displacement is actually a vector quantity. So basically distance and displacement we define. For that, first of all, we have to define two positions. We have to define two positions. While others are busy in studying, okay, busy in studying, and when they are giving correct answers, I am seeing one or two students, they are just busy writing doubt, doubt, doubt. They are not telling what is their doubt, they are just writing doubt. Okay. So better waste your time in studying rather than wasting time in typing doubt. So here displacement is a vector quantity because it has a fixed magnitude, direction, and it obeys certain laws which I told in our initial classes, that vectors obey certain laws of multiplication, addition, subtraction, and so on. So here displacement is a vector quantity, and for defining displacement and distance you need to first define two positions from where you are starting and from where you are finally arriving. Now once you have defined A and B, then finally what you can say is, if A and B are the same points, if A and B coincide, then what will happen? If A and B coincide, what will happen? So I will say that there will be no displacement. Why? Because if A and B coincide, the shortest distance which you are telling or straight line, that one will become 0. So if A and B coincide, the displacement will become 0. So this vector quantity can be having positive, negative, or even 0. So displacement can be 0 also. It depends on the initial and final position. If there is no change in position, initial and final positions coincide, then we say that displacement is 0. 0 word simply here signifies what? 0 means initial and final positions coincide. So if you use a language of physics, a phrase is used for this, we call this as round trip or closed path. When you start from a point and you again come back over there, your initial and final positions coincide, so the length of the straight line will become 0. Joining initial and final point, because they have become the same. So in that case we say it is a round trip. When you start and reach, whatever shape it is, you call it as round trip, or you also call it as closed path. Understood? What is positive and negative used? If the initial direction along which you were moving, the final position is on that side, then I will say displacement is positive. What was your initial direction of motion? If your final position is on that side, then I will say displacement is positive. And if your final position is opposite to the direction of your initial motion, you will say it is negative. See how? For example, suppose I am standing here. Just look, I will be done ending is. I am standing here. I am going this side. Okay. Now I came here. So I came to this new position. This new position is on which side? It is on the same side as I was moving initially. So I will say my displacement is positive. But suppose if I come back and I cross this point and come here. Now I was initially moving this side, but now I came here. So what happened? My displacement became negative. So when we have to say that displacement is positive or negative, we always should know what is the initial direction. If I know the initial direction, where you are starting, see the initial direction. If your final position is on that side, you will say displacement is positive. If your final position is on the opposite side, you will say displacement is negative. Distance on the other hand can never be negative, it is always positive. It just keeps on adding. If I move 2 meter forward, if I move 2 meter backward, total distance will be 4 meter. Displacement will be 0. If I move 2 meter forward and I come 2 meter backward, what is my displacement? 0, because I came back to the original point. But distance, I move 2 meter forward, I move 2 meter backward, distance is 4 meter. Distance is always added. This value is always added, always positive, always increases. It can never decrease. It has got no relevance for direction. For distance, you do not focus on direction, only for displacement. And in displacement, as I said, you just have to see that where the particle was initially, and from that position where the particle started moving. So initial direction of motion if you know, then if your final position is towards that side only, it is positive. If the final position is on the opposite side, displacement is negative. If the final position is on the initial position only, displacement will be 0. I hope this concept of initial, final, all these points are clear to all of you. So today we did not do any analytical treatment of these terms, distance and displacement. We just understood theoretical points. Tomorrow we will see distance and displacement applied to numericals, and then we will see the concept of speed and velocity. Not tomorrow, basically the next working day or Monday. So Monday will be discussing about the numerical aspects of distance, displacement, velocity, speed and all, and along with numericals. So from Monday onwards you will have a feel of solving numericals on physics. Okay. So what all I told, kindly go through the video once again. Those who had any problem regarding that, sir, we should write or not, I told, when you will be again seeing the video, listen carefully, put your headphones or earphones, what you have, listen carefully, make note of important points which you feel that yes, these are important, this can be used later. Make note of that. You will definitely be able to understand everything, right? So that will be all for today. So if you like the class, kindly, as we keep on telling, just you can share the video with your friends. You can ask them to subscribe as well. Okay, and we'll be trying to bring more interesting and informative contents in the upcoming classes also. Okay, thank you.